look at the zeros of the numerator, my x-intercepts.
Let me do this square root of 2.
And then obviously I would have to rationalize my denominator. So you would get, when you write that out, it would be x equals plus or minus the square root of 6 over 2. Multiply top and bottom by the square root of 2. Okay? So those would be my x-intercepts. Obviously, that's going to be some weird, crummy-looking decimal. Is that okay? Yeah. What was the decimal equivalent of that?
That is a good question.
1, 2, 3? 1, 2, 2? Okay. So it's about here.
We didn't have to graph it, did we?
No, you didn't have to, but what I'm doing here today is I'm going to start showing you guys how do you plot the basic information. Because when you plot the basic information, the rest of it is just using table function. Yeah.
So the question was over this and
What we did yesterday. I'm going to talk or 2 days ago, excuse me. 19. So then there's your x-intercepts. The next thing you'd have to find is your vertical asymptotes. Your zero of the denominator. So my vertical asymptotes can be at -2. I would put a dotted line at x equals, or y equals negative, excuse me, yeah, x equals -2, excuse me. And then finally, after that, I look at my horizontal asymptotes. In this case, my m value is 2, my n value is 1, so there's no horizontal asymptote. Okay? After you did that much, all you had to do is plot those 2 points, put a vertical asymptote. Now how do you finish the problem? This is what we're stepping off with today. What's that? Then you just use your table function. At this point, you have now shown me all the information that you need to be able to do as far as putting it on graph paper. After this point is when you're able to use your calculator to get the 4 sets of ordered pairs. So when I use my table function with this equation, we're going to get, I guess I can just use one on the board. Woo!
Everybody.
2x squared minus 3 over x plus 2. Is that right? X minus, or x plus 2, correct? So if I look at my graph, you'll see something like that. Now, in this case, I just go to my table, and I need 4 ordered pairs. Obviously, some of the ordered pairs are going to be real crummy looking, but it's just a matter of writing it down, okay? Excuse me, then going from there. All right? The other half of this graph just isn't shown up in your table. Obviously, if you look at it on both sides of your asymptote, you see how it jumps from -1, 1, then on the other side it's -3, -15. It's just not, you're not be able to see it via your window. And that happens from time to time. But could you still write down ordered pairs? Whenever you have a vertical asymptote, you want 2 on the left and 2 on the right. Okay? So let's see, let me put this here. And I can cheat because I can do this. There's my ordered pairs. Basically, that's what you guys are going to be doing anyway. 2 on the right, 2 on the left. Yes, sir?
So do you have to graph the ordered pairs, or can we just write them over there?
At this point, because then you're going to start graphing. This one you're not going to see because some of it's going to be bounded way down here. And then here, you know it's going to be going like this. All right? Excuse me. If there's graph paper, if the problem says graph it, then yes. The problem says list everything out, then list everything out. Okay? Well, we're starting that graphing part today. And the graphing part, like I said, graphing is just putting ordered pairs. Your calculator does it. There's no rhyme or reason. You just have to put them on the graph table. I would assume probably. But you still have to know how to find all the rest of the stuff. Because the table part will allow you to do that.
It's a test.
Which is the quiz.
Oh,
Yes, sir.
I was gonna say.
I know. You have to take it after school today. That's what I told you guys earlier this week. All right. All right. Next one. Again, do I have any zeros of the numerator?
No.
So I have no x-intercepts. So x-intercept here is none. Vertical asymptote?
None.
None again, because I'm looking for reals again. We're only graphing reals.
Oh.
And then lastly, if I'm looking for my horizontal asymptote, my horizontal asymptote
Is 0.
excuse me, the n value is larger, so it's going to be at y equals 0. Again, from that information, it's relatively simple to go to your table function and just start substituting points. Okay? Do I need to show you how to use the table? X-intercepts, zeros of the numerator. What are the zeros of the numerator? Yes, sir.
What did you get for the horizontal the last one?
0.
2. That's what I thought.
2 plus or minus 2. Vertical asymptotes. I have none. And then my horizontal asymptote is where? Very good. Remember, your horizontal asymptote is always going to be. Hey, I know you're excited. You're cheering for me to win pizza, of course. You don't have a singing fish. I've heard there's some tough competition out there. So, again, as we get into this, Mr. May, what can I do for you?
You fold the symphony card.
What was that? How do I find the vertical? Vertical asymptotes are always the zeros of the denominator, the real ones. In this case, I don't have any real solutions to the denominator, so there are no vertical asymptotes. So when I start substituting in again, I have a horizontal asymptote at 1. No vertical asymptotes, and I have x-intercepts at plus and minus 2. At this point, could you easily use your table function again? Good. Are these as scary as they first looked?
Yes.
What's that? X-intercept. Where's your x-intercept, if they have one? Negative 1/4, very good. Vertical asymptotes. Plus or minus 1.
Oh, I'm an idiot. Okay.
You're not an idiot, you just made a stupid mistake. I need to get that jar. Does anybody know whose Tupperware that is, speaking of jars and stuff? All of a sudden last week, oh, they're Tupperware. The silly mistake jar?
Oh, $1 for that was just what I meant.
But people left Tupperware, and I don't know who put Tupperware in here.
Why would someone bring Tupperware?
I don't know. It's just random. Horizontal asymptotes. Do we have horizontal asymptotes here? It is not. Your m value here is 1, your n value is 2. So n is greater, so your horizontal asymptote is located where? 0. Again, as you start substituting values, I know negative 1/4 is kind of about there. Vertical asymptotes at plus and minus 1. Horizontal asymptote at 0. And now it's a matter of tables. Yes, this is that weird situation where you wind up with 6 possible areas of your curves. What happens sometimes is you will cross over an asymptote in between the tail of the two ends. It's just one of those weird things that happens.
Is this a common thing though?
Yeah, a lot of times you see this. It is a thing that does happen. If you wind up with multiple asymptotes, vertical asymptotes, you're going to get that 6 boundaries, if you will. The boundary in the middle, sometimes it's sometimes a parabola, sometimes it's a curve, a cubic looking function.
Oh.
It will cross through where you believe an asymptote might be. But the asymptote is also being defined by the outer edges here. The outer curves are bounding that way as it's coming through, but yet in between it can be snaking through it.
So wait, but you said it might touch the asymptote?
Yeah, and this is that weird case when it's in between the verticals, when it's in between the uprights, because here I have an x-intercept. My x-intercept happens to be located upon an asymptote,
Yeah.
but that asymptote might have a different boundary line in between.
I was saying like if it's snaked up through it goes.
Yeah, it would go through that, and that's okay.
Yeah.
All right, that'll happen. That'll happen from time to time. It's not one of those weird things. You guys don't have to worry so much about it. As long as you know that you still have an intercept, like you say, intercept there, the asymptote's still there. It's not a big deal. Okay, you'll study more about that later on.
Okay.
Yes.
Wait, well,
On 29 graphs, you know how I did the little thing?
Yeah.
How do you know that that happened and it's not a program?
You'll use your table function.
I just
Yeah.
I got the point because it was
When you're
the intercepts and if you want to get points.
Yeah. What happens is you're gonna. I'm not gonna have you crank these out by hand. What I want you to be able to do is identify all the big chunks. From there, it's just a table, and can you look at a graph and fudge it through?
So for that one, because it's only like in that middle section, because there's only like 1 point in there. If we looked at the graphs and we just drew
That's
what
fine.
you should, so
That's fine.
Would you have to explain?
What's that?
Would you have to like?
No, it's something like this. It's not that big of a deal. What I want you, like I said, the main part right now, can you identify all the important features of pond that is occurring within that graph? That's the main idea. The curves and putting in the other stuff is a piece of cake. You can give, I can give that to an Algebra 1 kid. They can type that in their calculator and draw a picture. But they don't understand where asymptotes occur. See what I'm saying? Does that make more sense? Which one are we on? 30. Oh no, have to factor. Oops, I always forget that. Okay, so my x-intercepts are going to be at the zeros of my numerator.
which is a number.
So we have to go 2x squared plus 3x plus 1, set it equal to 0. So what times what is 2 that you add together to get 3?
2 and 1.
2 and 1. So we have 2x squared plus 2x plus 1x plus 1. Factor it by grouping.
It'd just be 2x.
Yeah, I just realized I did that. So you have 2x plus 1 and x plus 1. So your intercepts are going to be located at -1/2 and -1. Okay? Your vertical asymptotes are going to occur at the zeros of the denominator. What times what's positive 4 you add together to get -5?
-4, -1.
So it's x minus 4, x minus 1. So those zeros are going to be at x equals 4 and 1. And then lastly, your horizontal asymptote. In this case here, we have the same degree in both of them. When you have the same degree, what do you do for your asymptote? A over B. And remember, your A over B is standing for the coefficients of the highest degree, 2 over 1. Horizontal asymptotes are always y equals something. There's all the important information that you need to be able to decipher from the graph. After that, it's a matter of just using table functions. And like I said, that's probably the easiest thing you have to be able to do. -1/2, -1, 4 and 1. And then horizontal at 2. From there, again, it's up to you. Table, look at the graphs and go from there. If there's a graph problem like this on the quiz, you would have a space to write out your 4 sets of ordered pairs. Or in this case, you might need 6 of them, 2 in each of those spots. Okay? But you have a table. It should not be difficult. Yes, sir?
Wait, where would you need to have,
If you look at the graph on this one,
would it be before, like, before 1, after 1?
yeah, I'll show you what it would look like. Let's see here. It was what, 2x squared plus 3x. Oops. If I'm looking at this graph, it's kind of funky looking. It's ugly. So what you're going to want to do is you're going to want to find, like you're saying, get a couple of points to the left of 1, get a couple of points between 1 and 4, and a couple of points to the left of 4.
Okay, that's the right one.
Yeah, thank you.
Okay.
And that's what you're looking at being able to do. And again, your table function will do that for you. And this is nice because you have it's between 1 and 4, so you can pick 2 and 3.
Yeah.
It's that straightforward.
Okay.
And you can just do this. Go, oh, look, here's my fancy graph. Because I'm awesome. Just like my door.
Hey.
You guys are all jealous you're not in my 12th hour class.
Yeah, no. Yeah, mine is. I've Gunderson.
You know what? It's so funny. It's like you guys either have me for 12th hour or Gunderson for 12th hour. I think most of you guys have Gunderson. That's a wildly crazy time. Get it? Wild. All right, where's your vertical, or excuse me, where are your x-intercepts in this problem? Where's your x-intercept? Excuse me. 0. Vertical asymptotes. -2. Very good. Horizontal asymptote. And then lastly, putting a couple of plots together. And then table it out. Okay? Yippee-yi-yay, yippee-yi-yay, yippee-yi-yay.
I'm just making things up.
What would you
Yes.
say? What would you say?
I always forget.
What would you say is the most common?
What is the most common? It's, I don't know, give 1/3 chance on each one of them. There really isn't a common case. What they're trying to do is they're trying to space out all the different problems so that way you guys get an idea of seeing each of all of them. You know, they're trying to give you the opportunity to visualize, see how each one of them occurs. And go from there. So what I want you guys to be able to do, why don't you try out those last 6 right here, the 32 to 37. Again, identify all the important parts, and then try and put a couple things with tables together, okay? So, I've got some more graph paper. Some of these, I'm pretty sure most of them will get in there. So in here, again, same page, it's the last 6. Do the same thing we just did. What's your x-intercept? What's your vertical asymptote? Horizontal asymptote? And then give me a couple sets of ordered pairs. If it happens to be one of those problems where you have dual vertical asymptotes, make sure you get an ordered pair between them, okay? You always want ordered pairs on every side of your asymptotes. Give those a shot. I don't think you guys will have much of an issue. Remember, the stuff tomorrow is 9-2, 9-3. It's going to mirror basically what we've been doing. So you got to remember the other part of 9-2 where you had the A, H, and K, or your AX plus C, or yeah, AX plus C over CX plus, or AX plus D, excuse me, over CX plus D. So you got to remember a couple of those little rules there as well. Remember, it's again, it's just a matter of identifying your zeros, knowing where your asymptotes go, and then being able to use your table function.
What page is that on?
551, same page.
This is graphic.
Yeah, this is graphing. I'll get you some more graph paper, okay?